Hello, everyone, and a very, very good afternoon. Welcome to the CTO panel on digital technologies driving product innovation. So digital transformation, technology disruption, innovation, we've heard all these terms in the boardroom conversation, but how should we react? Welcome to the CTO panel, and my name is Preet Banerjee. I'm CTO at Ansys, and it's my honor to present to you a panel of distinguished technology leaders who are leading companies facing this challenge every day. For many of us, the COVID-19 pandemic has fundamentally changed the way we think, whether it's about the choices we make in our personal lives or how we run our business. The threat of disruption from a health crisis like the pandemic is unusual, but as business leaders, we see disruptions in technology on a regular basis. Typically, markets become disrupted when visionaries recognize that and then take advantage of a series of technological advances. These innovators take these new tools or new ways of thinking, or perhaps different ways of combining technologies together and help them coalesce into something transformative. In the process, entire industries are disrupted and fortunes can be made. And now we are on the cusp of the next disruption, that of digital transformation. This disruption will fundamentally change the way we think about innovation. It will level the playing field among startups trying to break into the market against our larger, more established competitors. So digital transformation, what is it, right? It's the use of digital technologies, which include things like cloud, mobility, Internet of Things, data analytics, AI, machine learning, additive manufacturing, all of these things. So use of digital technologies to radically improve the performance or reach of an enterprise, and essentially to drive these digital transformations to improve customer experiences or more efficient operating processes. So let's just look at some examples, right? When you look at the CRM space, customer relationship management, right? The old world was sort of Oracle, right? Everybody uses Oracle for CRM, but it was sort of disrupted by sort of going on the cloud, right? By Salesforce. Look at supply chain management, SAP. Everybody uses SAP's tools and so on. And sort of the supply chain management on the cloud is NetSuite, right? Disrupted by a startup. Same thing for workflows, like HR, right? HR on the cloud, everybody uses PeopleSoft. That was disrupted by Workday. And it just goes on and on, right? So you look at technologies like machine learning, AI, right? TensorFlow, PyTorch, NVIDIA's tools, Intel's tools, big data analytics, cloud data, Mapr. So there's so much stuff going on, right? In these new technologies, digital technologies, and some of the new entrants. Based on these technologies, there are entire industries that are being disrupted, right? You look at the auto industry, everybody sort of sees Tesla with electric cars, Waymo with the self-driving cars, Uber and Lyft with ride sharing, the hotel industry, Airbnb, the hospitality, and so on. In the manufacturing industry, IoT and automation, there are startups like Foghorn and Sight Machine. In the world of education, massive online courses, MOOCs, Coursera, edX, and so on. So entire industries are getting disrupted by these digital transformations. So today, what we have is the use of digital technologies to drive product innovation. That's what we are going to talk about today. And we have an outstanding set of panelists who will share their thoughts on the topic. Today, we are joined by Chandragan Patel, who is HP's Chief Engineer and Senior Fellow. I have had the pleasure of knowing Chandragan for many, many years when I was at HP Labs. He has led HP in delivering innovations in chips, in systems, in data centers, storage, networking, print engines, and so on. He's a pioneer in thermal and energy management in data centers. He has lots and lots of publications, more than 150 publications. He's a fellow of IEEE, he's a fellow of ASME, he's a member of the National Academy of Engineering. Amazing, amazing innovator. And you will hear from Chandragan later today. Second, Tirthankar Lahiri. He's a Senior Vice President of Data and In-Memory Technologies at Oracle. His area includes the Oracle database engine, the transactions, data formats, indices, advanced compression, database in-memory, all kinds of stuff. He's worked on the Oracle Times 10 in-memory databases, the NoSQL DB. He's got more than sort of 26 years of experience in database industry. Amazing, amazing sort of background. He is a BTech from IIT Kharagpur and a master's from Stanford University. Then we have Deborah Jethi Dutta, who's a VP of Engineering at Nutanix. He previously was a distinguished engineer at Cisco Systems. He started his career as a postdoc in computational biology at USC. He is also from IIT Kharagpur and a PhD in computer science from USC. Amazing panelists, great background from them. And I'm sure we are going to have fun today. So what I would like to start with is sort of the core topic that I've introduced, right? So we talked about digital transformation. So let's start with, if each of the panelists, starting with Chandrakan, if you can share real challenges and opportunities that you and your company, right? So you at HP, right? What are you facing in terms of challenges and opportunities in digital transformation? And as I said, right, that includes AI, machine learning, big data analytics, IoT, 5G, cloud, mobility, etc. Right? So let's start with you, Chandrakant.
Thank you for having me, Brett, and greetings to everyone. I think the digital transformation should be called cyber-physical transformation because of the challenges I see. In the list of companies you named very correctly, Tesla is an exemplar of a cyber-physical system. So the challenges we face today, I mean, if you look at my history, I started in disk drive chips and went from micron scale to kilometer scale at cloud. And when we got to the cloud and did all these wonderful things, digital transformation has been being driven in the financial sector, marketing, e-commerce, and so on, right? And we do that. But the real challenge lies in cyber-physical transformation. What do I mean by that? Let's say you are a 3D print engine and you have devices that are scanning the powder bed, and you have structured data coming from sensors, video data coming from physical systems. How do you avail that data? Use domain understanding, data management, and data sciences to infer and act upon it. So the digital transformation should be called cyber-physical transformation, and it must be understood with great depth in domain sciences. And the IIT is an exemplar. Growing up as a child, I mean, when I go to India, I go to Khanna Publishers and pick up books from the great faculty at IIT. So it's a world where domain understanding is absolutely critical. Understanding porous media, in our case, where we are heating it up, applying agents, and then making a part that is precise. So it's a domain understanding, data management, and data sciences. And I contend that we are stuck only on the digital and not so much on cyber physical. As an example, and I'll close with this. I know I have 3 minutes, so I've got a minute left. When my daughter went to interview at Tesla, I asked her to go on the whiteboard and tell me, and this is back in 2013, when autopilot was not even around. So I said, okay, how do you build the car? How do you size the motor? What is the wind resistance? What is the rolling friction? What are the actuators will you put on the car? What are the sensors you will put on the car? Because in a cyber physical world, you have to a priori put sensors and actuator or create a modular systems with the right actuators and sensors. Without them, no matter what you do with AI, no matter what you do with software, you're not going to autopilot. So you look at this example, a car was built with the right actuators, right sensors, and 2 years later, autopilot came. This is the world we are getting into. Much more difficult world that harkens the return to fundamentals. And I think we should change the conversation to cyber physical transformation, not just digital, physical digital transformation.
Thank you. Thank you, Chandragan. Thank you for a great introduction. So, Tirthankar, your thoughts on this topic?
Hey, thanks, Brett. So, yeah, that was very insightful to hear. I'm going to give you some examples from Oracle's history, more as examples than anything else, of adaptive transformation. First of all, transformation, the only thing that's consistent is it's permanent. There is always transformation, and what we're right now seeing is a trend for moving away from product-based innovation to basically building fully integrated suites of capabilities. If you think about, for instance, an iPhone, it's not a product anymore. It basically is literally a key to the Magic Kingdom by giving a massive capability suite. And that's the new sort of requirement to survive and to flourish in this digital transformation era. So as an example, Oracle, was before in the business of selling apps and selling databases and making hardware with the Sun acquisition. But, Oracle had to adapt to this new regime, this new paradigm where people people don't buy individual products anymore. So we have to transform all of our technology into basically cloud native services by reusing components when possible, acquiring technologies when possible, when it was practical, and in some cases building from scratch. And this, the decision about what to do, whether you should build, buy, or acquire, it's hard. It's not easy, and it requires a lot of courage because it needs to be able to walk away from existing paradigms and thought processes. But the effect was, Oracle has converted from being an applications maker to being the provider of a fully integrated application suite called Fusion Apps, which is now really a cloud native app service. Oracle Analytics Cloud basically incorporates many foundational technologies again into a full suite with built-in discovery, automation, self-serve AI, and collaboration. And on the database side where I work, Oracle has Exadata Cloud Service, which delivers database infrastructure at scale on the cloud. An autonomous database, again, reimagines data management in a world where you don't want to deal with setting up your database and deal with administering and tuning it. It's all done for you. It's self-driving, self-repairing, much like Tesla's vision for self-driving cars. We think self-driving databases are the future of data management. So again, my main point is change. The only thing consistent about change is change happens constantly. The era of building standalone products really for profit, it's not going away, but it's declining a lot. And now when you try to build technology, you really have to think horizontal integration and figuring out what to keep from the past, what to enhance, what to rebuild. That is going to be the ongoing challenge for future technology generations. I don't think I've anything more to say on this topic, so I can hand it over back to you, Prith.
Thank you, Tirthankar. So let's move to Deborah for his thoughts on this topic of digital transformation and challenges and opportunities, as you see it from Nutanix's point of view.
Deborah, I think you're on mute.
Oh, you're on mute.
Sorry. I'll start off with some internal and external examples. First, so internally, for example, if we want to see, let's look at what digital transformation is, right? It's basically leveraging data to make more intelligent decisions towards a business outcome. So if we look at the collective enterprise of our engineers, SREs, field engineers, and customers, how do I take all this knowledge and simplify our operations of our product line? And that leads to better customer satisfaction. And so it's a very hard problem. It sounds very simple. Oh, let's just throw some AI pixie dust on it. But what we've seen is that it's actually a bunch of challenges. It's a last mile challenge, first of all. For example, how do I get the data everywhere? I mean, data from diverse sources and have a unified understanding of it. And it's not just that what we are looking at. When you look at our customers, let's look at a traditional enterprise. They may have the world's best cloud tools for sales and order fulfillment, but many of their multiples of $1 billion of orders still arrive on the fax machine. Fax machine, yes. So the last mile problem is something that we see over and over again. And because the digital transformation cannot be just solved with software alone, it needs an organizational transformation. Organizations need to collaborate more intensely and speak the same language. So I think the problems with digital transformation is also, speaking the right language and consistency as a layering problem. So, for example, and this has happened over 30 years. If you look at the history of networking, there was no consistent way to computers to communicate with each other till IP came about. Similarly, with data, you have data formats, and now as we are moving into machine learning, we will need very consistent ways of representing models because it'll be the next gen code, right? And once you have all of this, and in addition to what Chandragan and Tirthankar said, right, you will need domain understanding, but more than domain understanding, once you have all the right technology, you're going to have to operationalize them. And again, there you look at the last mile challenge, the organizational issues, the layering of tech, and operational efficiency. So operational efficiencies will be key. For example, if everybody talks about AI, but it's only very recently people have started talking about machine learning operations. How do you put AI into practice, or how do you clean up data and have a coherent way to feed into decision making? So that's going to happen. And one of the things that I personally see is that open source has a big role to play, because open source because open source is basically a set of diverse people coming and building disruptive technology. You get cognitive diversity, you get robustness because you have different you have people representing different design patterns and different organizations that have thought differently. So that's pretty much.
Thank you. Thank you so much, Deborah, for your insight. So in fact, I'm going to sort of leverage what Tirthankar kind of talked about in terms of how Oracle is changing from building products to building suite of applications, sort of ecosystem. And then Chandragan talked about the Tesla, right? So as we look at products, how they were innovated, especially hardware products, when I was CTO at ABB or Schneider Electric, right? We had these hardware products that we built, and it took like 3-4 months of planning. Then we had the stage gate processes. It took like almost 2 years to come up with a new hardware product, right? Because you have to really think through all those requirements and so on. That is, the old world was stage gate, waterfall processes, and you make sure everything is done, you build the right product. Advance to 2021, right? It's the world is sort of the software world, cloud world, right? And continuous innovation, continuous delivery, where people are literally putting out products like at the speed of light and essentially doing continuous sort of innovation, right? The Tesla car that Chandragan talked about, right? I mean, you can have in the past cars, right? They went through all those kind of sort of all the requirements and so on, and then you launch the car. And now Tesla has this car, and they have the over-the-air updates every evening, right? So there are all these product features that are coming to the Tesla, right? And it's a hardware product which is actually working like a piece of software. So I want to kind of talk about how products are being innovated in the digital world today. I'm going to start with you, Tirthankar, because you kind of led this conversation, and then to Deborah and then to Chandragan. So Tirthankar, your thoughts around product innovation as it is happening today compared to what used to happen in the past?
Sure, it's a really good question. So first of all, I mean, terms like agile, waterfall, stage gate, these are all good concepts and terms, but the really important thing is to be smart. The smart model is what's important, because you have to do what's appropriate for each level of your stack. If you think about Tesla releases new vehicles rarely. The distance in years between Model X and Model Y was not, is not insignificant. But they rev the user experience regularly. So this is the thing to think through, is that there are certain things in the stack that you need to rev rapidly to meet customer requirements and to fulfill, key enhancement requests. At the same time, you've got to protect and make sure that your industrial strength platform that you've built this on is released at the right cadence so that you can have high quality. So at Oracle, for instance, we have this, what we call a holistic approach. For things that involve UI, UX, APIs on the cloud, we rev them very frequently as 2 weeks in many cases, using CI/CD pipelines. Our Fusion application suite, which is, again, as I mentioned, a fully integrated app suite, that's updated a little less frequently, but every 2 to 3 months as well. Cloud infrastructure generally updates once a quarter, and typically really big changes like changing the platform, like adopting a new processor or a new major database release, those happen less frequently, like once a year. And of course, CI/CD nowadays is empowered by a lot of new developer frameworks like Jira, Kanban, etc. However, for the key core infrastructure of the cloud, basically servers and databases, right? We have to use a different approach there, because the problems inherently are very, very complex. Intel can't release a new generation x86 chips every week. It just wouldn't be viable. So what we do there is we follow a different process there, where the development is modular, and the testing is done, of course, initially in each developer sandbox environment that converges the integrated framework with continuous rigorous daily integration to make sure the overall product line stays robust. And then we release the database, or say Exadata, which is the database platform, typically at a longer cadence, about once a year, to make sure that what we deliver is of high quality. But we make sure that in the process of doing that release, during the release period, all the products, all the features are tested harmoniously together. So what finally gets developed is a converged and complete product. So I call it basically being smart. You've got to be agile, you've got to be nimble, and you've got to protect your key assets by doing the right diligence and the right discipline and rigor to make sure the product quality remains high. And it's true for Tesla, it's true for Apple. The iOS versions update much more frequently than the iPhone hardware, which is what people expect anyway. Nobody wants to buy a new phone every month. But people want to see new iOS features regularly, and Apple is very good at pushing those out. So the cloud demands that. Rev the UI, rev the UX, rev the apps quickly, and make sure when you rev the hardware and the platform that you deliver a very high quality product when it's finally released to market. Over to you, Prith. Prith, you're on mute.
Yes. So let me hear from Deborah on this topic. And I'm watching the time. I don't think we'll be able to go through all the panelists for all the questions, but I do want to go through the questions. So we're going to ask Deborah to address this issue of product innovation. Then I want to go into the topic of the core versus disruptive, and I'm going to start with you, Chandragan. So Deborah, talk about the product innovation approaches.
So I totally agree with what Tirthankar said, and due to the lack of time, I'll just add a couple of points. So if you think about CI/CD, and you call it continuous innovation, I'll put a different twist. How do we do our continuous innovation in a company that's already gone public? It has its own priorities. So one of the things that one of the things that people can do, any company, and we are also doing some of this, is that we always set aside, as Tirthankar said, that you have to be smart. You have to have a different way of thinking for your core products, and you have to set aside some resources and some cycles for next generation innovation that's disruptive, and it'll be in both core as well as adjacencies. And then the other thing is that we have to figure out that the cloud being a delivery platform where you can actually innovate much faster. How do you do it in a way so that you can then bring back into the core products? So that process is something that we are working on, how to make it more efficient. Being engineers, we all like to innovate. So if we look at our organizations and we assume that every engineer is a next-gen innovator, how do you harness that enormous energy and ensure that what they are doing can go into your product line? So there is a smart way of having the incubation, looking at adjacencies, having an incubation, being disruptive, and then ensuring that we can get back to the core product line. So I think that's something that we've been doing at Nutanix pretty successfully and built adjacent products. And right now we are doing that in the next gen workloads like AI, ML, and also in core strengths.
Thank you, Deborah. So let's now talk about a very an important topic that I'm very passionate about, sort of core versus disruptive innovation, right? So we all know that, when you look at Kodak and they knew about digital imaging. It's not like they did not know about digital imaging, but they wanted to protect their cash cow of their analog printing, and they essentially missed that thing, right? So it is very hard for large companies, well, they know here is the innovation coming, but because their core business is in that area, right? They're hesitant to move into the other areas. An example of a company that actually did that well is Apple, right? They saw the iPod business, well, good business, etc., and they were about to invent the iPhone. The iPhone would actually kill the iPod business, but Apple went ahead and did that anyway, because if they don't, somebody else would have done it, right? So that was sort of Steve Jobs' view. So I want to talk about this whole area of large companies, right? Again, how they do disruptive innovation. As we are preparing for a panel, I talked about the thing that large companies do well in the incremental, the Horizon 1 innovation, right? You have a current set of products, you want to do the next product, next quarter, next year, etc. That they absolutely master. They also do well in the sort of the adjacencies, right? So the Horizon 2, well, I want to go to, I have a current product, adjacent product, that also they do well. But most large companies struggle when they are coming up with disruptive innovation. So I want to start with you, Chandrakan, right? Since you and I kind of worked on HP Labs and we were part of this journey on these big bets and so on. And you led this work on the sustainable data centers and so on. So why don't you talk about your thoughts on how large companies sort of succeed in disruptive innovation?
Yeah, and I'll add one more word, because your second question was very important too. The DevOps, you mentioned cloud software. I think DevOps needs to be cyber physical DevOps as well. And I like to Thankar's point of view on how do you do that in the hardware. And he was saying the revs in hardware. It's the way you do it is through modular hardware and with modular sensors, particularly in light of sustainability. I think it's a discussion we ought to have in Silicon Valley on what is cyber physical DevOps. I really love DevOps, but when you have to do complex physical systems, that rev is critical, and how do you design the physical system? Now, let me get to this other question, because your questions are very good. I really wanted to go after that one too. But this particular one, I think, Prith, what we find is the large companies, when you and I were together, we were looking at trends. We are very good at looking at trends. We are also very good at visualizing systemic solutions in light of the socioeconomic ecological trends. Where we end up faltering sometimes is the agility in creating such a systemic solution. Because we often think of devices. We don't think of multiple disciplines manifesting themselves in a solution. So the challenge lies is when you see the trends and you look at systemic solutions, you got to ask yourself, what are impedance matched to your company? So in our case, 3D additive manufacturing is impedance matched because some of the way we jet fluid agent on a porous media, build 3D, these are all complex physical systems that we understand. Microfluidic systems for healthcare application, possibly an extension of that, is another place where it's impedance. But then there are others which are faster done, better done by agile startup. And so, we recently, HP acquired Teradici. It's a great acquisition. I am a mechanical engineer. I use Z Workstation. And here's a company that had innovated, how do I get this high performance desktop that I have physically? How do I get it remotely? That's something that was done outside. So bringing that as an acquisition in is an example of how you try to disrupt your core. You're still in the core of computing business, but how do you bring something from outside that provides disruption and continues, otherwise the core would become very much a legacy. So I think you have to think in this way, impedance matching in light of the systemic solution.
Thankar, any thoughts on core versus disruptive? And again, you are at Oracle, I'm sure facing this issue all the time, but there are some amazing acquisitions that Oracle has made. So your thoughts on core versus disruptive?
Sure, I'll try to be short this time, sorry. I know I spoke a little extra last time. Oracle, I've been at Oracle for many years now, but Oracle has, been reinventing itself periodically throughout my tenure there. We began as a database company, we became a database plus apps company. Then we decided to buy, these mega app companies like PeopleSoft and Siebel. But we didn't stop there. I thought PeopleSoft and Siebel are great businesses. Let's just, that would be a huge money stream for Oracle. But Oracle decided then to build an integrated app suite out of those acquisitions called Fusion Apps. So instead of incrementally enhancing existing technologies, the courage Oracle had was to say, look, we're going to build something brand new, ground up, leveraging the assets from these acquisitions and internal IP. Another thing that we did was to buy Sun, which was an unexpected acquisition by Oracle, which gave Oracle a huge edge in becoming a platform for the enterprise by having both hardware and software. In fact, that's what's allowed Oracle to become like a cloud player, because without that technology, we couldn't have built data centers and servers and networks. On a smaller scale, we acquired a company a product team that I managed called the times 10 in-memory database, when it was clear that times 10 represented a style of data management that was in memory, which databases all start adopting very soon. And this caused synergy that caused a lot of in-memory innovation within Oracle. Actually, times 10 was a product of HP Labs research. So, HP Labs has a long history of having a lot of fingers in many innovative products built in Silicon Valley. Plus, of course, Sun also gave us the MySQL database, which is the world's most popular open source database. And recently, we have added an in-memory accelerator MySQL called HeatWave that brings real-time analytics to MySQL. So a lot of continuous adjustment of priorities and not organically focusing on incremental enhancements, but reimagining the stack is the way I've seen Oracle operate over the last 25 years that I've been there.
Thank you so much. Thank you. Great insight. So on that theme, I want to kind of talk about how it is possible for larger companies to tap into the minds of people outside the organization, right, to bring this disruptive innovation. And when Deborah was talking about the use of open source, it sort of triggered my thought, hey, we should talk about this topic of open innovation. So open innovation is something that was formally defined by Professor Henry Chesebrough at Berkeley as a way to bring, through partnerships with universities and startups, right, whole new disruptive ideas into the larger company. Because again, when we were at HP Labs, we used to practice innovation with the observation that not all the smart people work at HP Labs or at Oracle or at Nutanix, right? So open source is one way of bringing those kind of sort of technologies here. But can you sort of, let's start with you, Debo, right? Any thoughts on how you practice open innovation in larger companies, right? Maybe in Nutanix or you were at Cisco earlier, right? How you have formed partnerships with open source, academia, startups, etc., and bringing those disruptive ideas to the main enterprise.
So that's a great question, and it's close to my heart. So in my previous company in Cisco, I used to actually spend some time even at Stanford on campus as a visiting scholar. So that helped me kind of be in touch with academia. And also I worked closely with quite a few academics back then. And even now, I'm in Nutanix, I'm trying to do that. So I feel, if you think about what the research labs did, they created this new body of Horizon 3 work. But now academics are doing that new Horizon, Horizon 3 work all the time. So the way to do it is to collaborate with them in a very open way rather than worrying about the IP issues. And the way to do that is to do it in open source so that it's all open. This leads to new academic work, PhD thesis, new product innovation. Look at new companies being created in Databricks, for example. And the other thing that we do is that we partner with startups. Like Nutanix is not as big as HP and Oracle. So we partner with startups for joint solutions. So for example, there are a lot of startups who are looking at brand new workloads, genomics, AI, and whatnot, right? And large, high throughput computations. So we are very interested in them because when we do a solution with them, we kind of get to see the next gen. So that's like our Horizon 3. We get to see what's going to happen. So those are the two things that I routinely do. Like I always keep in touch with academia and always keep contributing to open source.
Fantastic. Thank you. Chandrakan, I know you have lived in Silicon Valley. You're always, I see you in all kinds of events and so on. Your thoughts on partnering, right, with university startups and other sort of this practicing open innovation?
I think Deborah did a great job on startups. So let me just talk about the universities in this context. So it was very much ingrained by the way you approached it, Prith, when we worked together. We look at the trends, we look at the systemic solution, we think of the entire multidisciplinary stack that makes up a solution. In light of that, we delineate key scientific and engineering challenges. And we realize that these scientific and engineering challenges are best addressed with our academic colleagues. So you'll recall when you were at HP Labs, we discerned that multi-input, multi-output closed-loop control systems is going to be critical. It is critical for me today when we are building these complex microfluidic systems. It was critical back then for data centers. So we chose to partner with the right faculty at Berkeley and other places so that we could innovate the control system, the closed-loop control system. So I think the way to think about open innovation is to holistically look at the trends, think of the systemic solutions, think of the entire stack, think of the key scientific and engineering challenges, think of the partners that you could have, and Jethi talked about the partners, they could be startup, and then think about the talent you have and what are the gaps in your talent. And now that will give you the opportunity to understand in a very laser-focused way, what is it that you want to focus on with academic, open innovation. I think that's the approach to that works for us.
Absolutely. Thank you again. So I'm going to skip Tirthankar, not because there's so many other questions to kind of talk about. So let me go to the future, right? So disruptions you can see on the radar, right? And so essentially the context is, as I mentioned earlier, right? Kodak knew of digital imaging, yet they held on to analog printing, right? And Nokia knew of digital cellular technology, and they held on to the analog phone business and so on. So now you are all technology leaders, right? You are seeing different technologies that are on the horizon, right? In my introduction, I said, okay, digital means what, right? It means cloud and mobility and big data analytics and so on, right? So what are the kinds of technologies that you see are disruptions? So, I mean, do you see quantum computing? Do you see blockchain? I mean, what is it that you see on the radar that you say, oh my God, this is going to be disruptive, right? So I'm going to start with you, Tirthankar, right? And this is your chance to be really futuristic, right? In the next 10 years, right? And this one, I'm going to go through all of you, right? Because you are technology leaders, right? So we're going to start with you, Tirthankar, then Debo, then Chandragan, right? To look at and then we'll take questions from the audience. So, okay. Tirthankar.
I'll try to be quick here, but the main, one of the things happening right now is application architectures are going through a massive transformation. We're moving from tightly coupled designs to loosely coupled designs involving microservices and events. And the traditional database architectures don't really work very well for that model. So we've actually built a whole new approach to microservice-based applications involving in-database virtualization, sharding for massive scale, transactional support for event management, so that you can handle applications not just that are built today, but built in the future, because more and more moving to decentralized app development. So that's a disruption that's happening, and it will keep happening for the foreseeable future. In terms of hardware trends, with a number of very exciting things happening now, ARM is a new compute platform that's really going to disrupt the traditional x86 market. GPUs are another type of computational unit that are very exciting. They don't do all possible operations, but they're very valid to accelerate specific workload aspects with. And looking ahead at seeing how we can leverage them best is very, very important. Persistent memory is something I'm very excited by. It's a brand new memory technology, probably more disruptive than Flash. Flash basically made I/O faster, which is great. But persistent memory basically eliminates the need to do I/O. That you have data in memory that you can manipulate directly and make durable without having to do any system calls or I/O calls. And this is a transformative memory technology, I think. Now we have a few initial capabilities that leverage persistent memory in the Exadata stack, but a lot more work is needed to really reimagine data management for persistent memory. I do think quantum computing is a very big deal. It's imminent. It's happening. And it's going to render existing security technologies obsolete. The database is a complex product with a lot of security aspects to it. So we're working on building quantum-resistant algorithms in the database, so that when quantum computers become reality, we have a secure database that can deploy mission-critical enterprise applications. Change, like I said, change is permanent. Change is constant. So being vigilant, being aware of change, and being aware in advance of the change is very, very important. Proactive response to change.
Thank you, Tirthankar. I'm going to go to Deborah, Jethi. I'm so glad you didn't mention AI/ML, because ML is what Deborah wants to talk about. And Chandragan, think about the amazing innovations you're doing at HP. Okay, Deborah, so talk about things that Tirthankar did not mention.
Yes, absolutely. I'll talk about two techs and a couple of apps that I'm interested in, and instead of talking about what Nutanix is doing, etc. So I'll tell you in terms of tech, instead of talking about general ML, because ML is a buzzword, I'll be very specific. I think there's going to be a huge, it's already happening. There'll be a huge inflection point where machine learning systems will become so cheap that you can train petabyte scale models very efficiently, and every enterprise is going to do that. And when I say petabyte scale models, it's not about training on petabyte scale data. That's one challenge. It's when the model parameters are in petabytes. So petabyte scale model is a grand challenge problem, in my opinion. And it'll need totally new, different technologies in compute, networking, storage. What Tirthankar already mentioned a bunch of these. And I think networks has they have to go faster and faster, and you'll see silicon photonics. And silicon photonics will also enable not only fast networks, but also could enable quantum computing, right? In terms of applications, so if you think about tech, why do we do tech? Because of the killer apps that run on the platforms. So if we build, as technologists build the world-class platforms, what are the world-class next-gen apps that will completely disrupt? And I mean, I know everybody's talking about blockchain, but effectively what I'm looking at is like, what are algorithmic monetary policies? Like, in a very simple way, what's the value of the money in your bank? Once you start thinking about it, and how do you transact? So using algorithmic ways, you'll get to a totally different future. In healthcare, like genome sequencing, and that's related to what Chandragan also mentioned, cyber-physical. How do you sequence long reads and all that using nanopore and other technologies, so that you can really get sequencing in a USB stick, and then with that you can do machine learning. You can apply machine learning to all the data, but essentially do continuous monitoring at that microscopic level. So you'll do totally different set of therapies. And
thank you, Deborah. I'm sorry, I'm trying to get to some audience questions. Chandragan, your thoughts on truly disruptive technologies that you see on the radar.
So, Prith, here we are in COVID, 2 years on. It takes 2 days to get PCR results. We should not call ourselves the most advanced region, for that matter, the most high-tech people in the world. It is bloody embarrassing, right? So I think if there's one thing that will happen, given my career in Silicon Valley, when I started, we had multi-chip module the size of this postage stamp, CPU, MCU, GCU, first level cache, second level cache. We had signal, power, and ground on a multi-chip module. We are back there. We open up. Now everybody's building MCMs, interconnect and packaging. I think the future, in 10 years from now, we will have multi-chip modules with fluidic connections. So there will be microfluidics chips with integrated sensors, actuators, do tests at speed. This nonsense of waiting 2 days for COVID is pathetic. So what will happen is you'll have multi-chip modules, hundreds of them in an enclosure, and hundreds of enclosure in a rack. And there'll be hundreds of racks in a data center. We will give rise to microfluidics data centers with signal, power, and ground. And what Jethi was talking about will happen at speed. And if that doesn't happen, forget it. We are wasting time. Because at the end of the day, we must address a trend that is a problem to humanity, at the same time be good business. So I think in 10 years we will see that, and this will be all the things that Tirthankar and Jethi is talking about and coming together. And I can literally visualize that. And if I had time, as you know, Prith, I would like to go on the whiteboard and sketch out these multi-chip modules and systems. It's a very exciting time. And now think about DevOps in this context. Now think about AI and ML in this cyber-physical world. And you will be glad you went to IIT and are such great depth in domain knowledge. I wish I had gone to IIT and gathered your depth in domain knowledge.
We are getting to the end. I want to make sure we have a couple of audience questions. So as we were so passionate about it, there were some questions that came in. A couple of questions on cyber physical. This was evoked by Chandrakan's very passionate introduction, right? Was cyber physical transformation. So the question is, as CPS evolves over time based on usage patterns, right? How should designers think about building such cyber physical systems?
I think, Prith, the key thing is we must codify domain knowledge. So, for example, when Jethi was talking about continuously monitoring physical system, that will not suffice. So think of the Tacoma Narrows Bridge that collapsed. We'll have thousands of sensors, we'll have cameras. If we are thinking about collecting data and letting it get to the cloud and analyze it with historical data mining, that's not going to work. As a mechanical engineer, all I want to know is that camera, look at the bridge and discern the amplitude, frequency, and mode of vibration. And a text goes out. So in other words, in order for cyber physical systems would have to succeed, not everybody could be a domain expert, but the domain expert who are today, and many of us will retire in some time, will need to codify their domain knowledge, and that thermomechanical modules, much like what you do at ANSYS, will have to be built with domain understanding so that it can be used to discern at the source of data. We cannot afford to send all that video data to the cloud. We can't even send it to a local micro data center. We must make the decision at the source. So the most important thing that must happen for cyber physical systems to succeed is codification of domain theories.
Thank you, Chandragan. So there's one question, last question that came out. Wow, this is a question to me. Hi, Preet. Some people call you the father of parallel CAD. Could you talk about how you managed to drive innovation at industry scale? Hey, this is actually a great question. This ties into some of the things that we do. So some of you know that I used to be in academia at the University of Illinois and Northwestern, where I used to do work on parallel algorithms for CAD. The year was 1990, right? 30 years ago. And this is exactly what universities do. Universities always do research on the absolute future, right? And at that time, I was doing the stuff, right? My students, many of whom were in the Silicon Valley, right? They got their publications, etc., but industry didn't care, right? At that time, Mentor, Cadence, Synopsys, nobody cared about parallel CAD. Advanced to 2020, right? Now I'm CTO at ANSYS. ANSYS is a $2 billion company. Today, all of ANSYS tools, they're leveraging parallel algorithms, right? Their HFSS tool, electromagnetics, runs on parallel, right? On message passing and shared memory. Fluid simulation runs again on everything, including GPUs that Tirthankar talked about. So it took 30 years for the industry to embrace parallel CAD, and ANSYS makes, of the $2 billion, $300 million of money, revenue on the HPC license. So I'm thrilled to see that the work that we got started with my graduate students at Illinois and Northwestern has actually seen the light of day. This is the kind of disruptive innovation that academics do, startups do, and so on. So again, thank you for the question. So we are out of time, and I just want to kind of conclude by saying that by leveraging the power of digital technologies, visionary companies like HP, Oracle and Nutanix and others, right, that we see in Silicon Valley are able to define their future and essentially direction of entire industries, right? And again, we don't want to be like sort of the Kodak, right? Each of us want to see what's out there, right, and prepare for the future. And the most sort of innovative companies, look at Amazon, right? They started on selling books on retail, and then they went to, okay, not just books, let's sell everything, and it became the platform. And then they went into sort of cloud and cloud services, and now they're the platform. So that most innovative companies keep redefining themselves. This is the core of our panel discussion. So at the Bay Area Leadership Conference, exactly, we have a lot of executives, a lot of designers, analysts that have come together. Hopefully the attendees got energized about this panel. I want to thank all the panelists. It is sad that we couldn't have met in person, but this group of panelists have decided that we are going to have wine together next week. So we'll get together. Thank you all. Thanks to the Bay Area leadership for giving us the chance. Great to see you all. Bye-bye.
Thank you. See you. Bye-bye.
Thank you. Bye.